All right, welcome back. So now we're getting to angle side acute angles, which is, I'm sorry, but they're not cute, even though they're acute angles. Haha. Okay, this is the one that's really the pain. Okay, so there's three different things that could happen. One of them could happen in two ways. I know, it's crazy. Okay, so first let's talk about how we're gonna draw this. Okay, I'm always gonna draw this the same way. Okay, remember, you're given one angle, okay, two sides, one of which is adjacent and one of which is opposite your angle. Okay, so that means I'm going to always draw it one very specific way. So I'm going to draw this line sort of going out forever. Let me draw it straighter. Okay, I'm going to draw one line going out forever like that. Okay. It's not that it goes out forever, but it's just that's the side I don't know. Okay. I'm going to draw my other side sort of going off of that side. Okay, so there's my side, and then I'm going to always consider this to be the angle I know. Okay, so this is my adjacent side, and then my opposite side is going to be off this way. Let me draw it this way. I'm drawing it this way to suggest something, but it's not coming out the way I want. Let me do this just again. Let me do this in a different color. So there's my adjacent side. And here's my opposite side. Okay, I'm drawing it this way, like I said, to suggest something. Okay, so as you can see here in the way that I've drawn it, I'm not really going to be able to make a triangle, am I? Okay, because if I bring this around here, it doesn't look like it's going to close. Okay. The way that I've drawn it. Okay, so the one I've drawn doesn't close. Okay, and what's happening is this is the case where you have zero triangles. Okay, what happened when you have zero triangles? What really happened mathematically is that this number h, which which is going to be the adjacent side times the sine of theta, is bigger than my opposite side. Okay, so this is where we have zero triangles. If the adjacent side times the sine of the angle is too big, bigger than the opposite side. Okay, so as an example, this is number 52, and we get this information. A equals 62 degrees, A equals 30, and B equals 40. Okay, so like I said, this is a angle side, one side opposite, one side adjacent. I'm going to draw it in my usual way. So the usual way is now infinite line down here that represents my unknown side. Let me try that again. Okay. Draw a side here. Move this information over. Okay. Put my angle here. Okay, A equals 62 degrees. B here is 40. What's my height? My height is 40 sine of 62 degrees. So that comes out to be 35.3. Okay, and so my A, which is 30, will never be long enough to sort of block this pathway. Okay. Okay, so we don't get any triangles, 0 triangles. Okay, that's the first case. We're going to go ahead and do the next case. Let's do it here too. So the next case is we could have one triangle. Now there's 2 different ways we could have one triangle. As you can see. The first way is pretty straightforward, and I'm not even going to cover that. If H, which is again the adjacent side times the sine of theta, equals the opposite, then you get one right triangle. Okay, there's another way that you could get one right triangle though. So let's draw this again. Okay, so that's my, again, my as yet ungiven side, or not given side. Sorry, I want to make that straight. Okay, there we're going to be given again an angle, side, angle, or an angle, angle, side. Angle, side, side, sorry. So we're given an angle theta here. We're going to be given the adjacent side. Now, if the opposite side is bigger than the adjacent side, then yeah, we can have a triangle over here. Let me draw that a little more exaggerated. Okay, we could have a triangle over there, but what's going to happen if I try to do that over on this side? If I try to do that over on this side, like I try to take something this long and put it on the inside of this triangle, it's not gonna work. Okay, this side has to be less than the adjacent side. So if we have the opposite bigger than the adjacent, then we're only going to get one triangle. Let me change the color on that, sorry. So, or if the opposite is bigger than the adjacent, we get one triangle, not necessarily right. In fact, not right at all. It's only right if those, if this is happening. Okay, so let's take an example. Make a little bit smaller so I can fit the example here. Ah. Okay, so as an example, give me a second to find it. Here we go. Number 48 gives us A equals 36 degrees, A equals 30, and B equals 24. Okay, so in this case, we have exactly that. A equals 36. So let me draw this picture again. So my angle A is 36 degrees. Okay, my B is 24. Let's check my height. My height is 24 sine of 30, which actually is going to be less than 24, isn't it? Right? Because sine is always between 0 and 1. So actually, in this case, I don't really need to check the height. Okay, and my A is 30. So my A is 30. There's no way that I can fit something 30 whatever long in that little space. The only place I can do it is out here. Okay. And again, I can solve for this quite easily, right? I can solve for let me do it over here. So I can say, okay, sine of B over B equals sine of A over A. Okay, this means that sine of B equals B sine A over A. Okay, which gives us 24 times 36 sine divided by 30. That's 0.4702 ... Taking the inverse sine of that, I get B equals 28 degrees. Now, again, you might also ask, well, what about the other angle that gives us that sine? What about 151.95 degrees? So 152. What's wrong with that? Again, the angle sides have to correspond with the side lengths, okay? So since side A is bigger than side B, angle A has to be bigger than side B, so that one's out. Okay? All right, we're gonna continue on the next video with one more angle side or angle side sides example, okay?